Hello everyone, my name is Jorrit Mesman, and in this video I will tell you about dynamic modeling and how this can be used to study lakes. First of all, what are computer models? Computer models are sets of mathematical equations that are used to simulate real-world events. And dynamic modeling means that your model will vary over time. Now, I don't know if this definition helped you a lot. It might sound very abstract or confusing, but it doesn't have to be complicated. And in this video, I want to show you a very simple example of how a model could look. So if you've watched some of the previous videos in this series, you will know what phytoplankton is. These are small floating plants that use sunlight and nutrients to grow. And you usually use a model to study a particular question. And let's say that our question in this case is how much more phytoplankton would we have if there was 4 hours more sunlight? So basically a comparison between winter and summer. Let's only focus on sunlight. Let's say there are enough nutrients, that temperature is not important, just sunlight. You often base a model on previous knowledge that you have about your ecosystem. And in this case, let's say we have a set of fictional experiments. Let's say that phytoplankton grows by 10% each hour in sunlight, and in darkness, phytoplankton dies by 8% each hour. And we will make a small model in the computer program Microsoft Excel. Some of you might already know this program. However, you can even do this exercise with pen and paper if you want. It might take more time, but it is definitely possible. Okay, let's go. So here we are in Microsoft Excel. I've done a little bit of preparation. So here we'll see this the time in hour of the day. So we start at midnight, and then every hour we continue. And then in this column, column A, we have whether there is sunlight or not. So of course, in the night, there's no sunlight. And then in the morning, here at 9 a.m., the sun rises, and then the sun sets at 7 p.m. And usually we express the phytoplankton in milligrams per liter, or in quantity per liter. Let's say we just start with 1. So now let's start to make our model. We type if this cell for sunlight is no, if there is no sunlight, we will multiply this cell by 0.92 because you get 8% less phytoplankton in darkness, remember? Now, if this cell is not no, it's yes, that means we have sunlight and that we multiply this cell by 1.1. We have 10% more. So that is our equation, and what Microsoft Excel does, if you double click here, it will drag this cell all the way down and does this calculation for every step. And now, if we want to put these values in a graph, there we go. You see, you start at 1. In the night, you get less, then the sun rises, phytoplankton starts to grow, and in the evening, it goes down again. And with these settings, we have a bit less phytoplankton at the end of the day than what we started with. So that is our first model result. Was quick, wasn't it? But now the good thing about the model, it's a bit more than just a calculation. You can actually change some things in there. And remember, our question was, what happens if we have 4 hours more sunlight? So let's do that. Let's go to 8 a.m. and say we have sunlight then and sunlight then. Now we have 2 hours more sunlight in the morning, and let's add 2 hours in the evening as well. And the program already calculates the new values. And let's put them in the graph as well over here. And there you see what we have. So now the blue line is the scenario with little light, winter, so to say, and the red line is the scenario with more light. You see that at the end of the day, you have about twice as much phytoplankton as you would have in the scenario without the extra sunlight. And this is one question that you can use a model for. So that does lead to the question, what happens when it becomes more complex? We just looked at the effect of sunlight on phytoplankton, but phytoplankton also needs nutrients to grow. What are the effects of that? Temperature is important. If it's warmer, phytoplankton grows faster. And water depth, deeper in the water, there's less sunlight. How does that work? And then there's wind that can control how much phytoplankton is at what depth, and well, how does that work? But you just have to realize that we don't have to do all this work ourselves. Scientists have been working on these questions for a very long time, and many of these processes are included in many existing lake models. And it's these lake models that we usually use to study questions like the one I showed you today, but also a bit more broader questions, such as the effect of extreme weather events on lake ecosystems. All right, so this was a very short introduction to dynamic modeling, and I hope you learned something about this today. So thanks a lot for watching.